on. Trust
Hi,
you
Victoria.
have a great day.
We start now.
Can you hear me? Hi, please confirm.
We can hear you, but it's breaking. But we can hear when it comes.
Okay, thank you so much. Okay. Let's see the slide.
Can you see my slide? Hi, everyone. Good evening. Victoria, can you see my slide?
Yes, we can see your slide.
Okay, thank you. Everybody, my name is Doreen, and I'm a data engineer.
Showing me how.
I didn't get that. What did you say?
Yeah, please, you can start. My network is throwing me out. Let me kindly try to resolve it.
Okay.
I'm so sorry for this.
Okay, no problem. No problem. So, good evening, everyone. My name is Doreen, and I am a data engineer. I work at Glouse Technologies. So before I even start, I want to commend everybody for being here and for taking this brave step to, being in data or being in the data track. It's not an easy decision, honestly. I understand how it can be because I've been there once. And most of the time, most people don't even know which track to go to, which tech stack to learn, right? And that is why I really commend the organizers of this, because when I started out, I also had like trouble deciding on which track to choose. I mean, I know I did a lot of try and error before I found data, right? So I'm glad that you guys took this decision to be here. So I would like my session to be interactive, meaning I want everybody's feedback and I want everybody to like be involved in this, right? I'll ask questions, and will also ask me questions. And if you have questions, you can drop your questions on the slide. I'm sure that it's already on the chat link, right, Victoria?
Right, I'm going to send the code to the chat now. Thank you.
Okay, so you can drop your questions along the way so that we don't break. Then once we're done, I'll answer questions, and then I also ask questions to make sure that we're all following, right? So my name is Doreen once again, and I am a data engineer. I work with a startup called Glouse Technologies, where I help in building data pipelines, right? And also enhancing data workflows, right? To also ensure that our data systems, our data warehouse systems are up to par. So apart from just working in startups, I'm also an active member of the data community, where I also like share my insight and resources with fellow engineers and fellow analysts in the field. I'm mostly involved in the Women in Tech initiative, right? So from Bootcamp to almost all Women in Tech initiative, I'm like a member. So yes, that is what I do in my free time. And then I also love reading too in my free time. So yes, thank you very much. So moving on. So like I said, you can ask your questions on the slide, which Victoria will be dropping in the chat. And all this class will be recorded on YouTube, so you can check it out after if you want to go over it again. Now, this is what we'll be treating today, right? So today we're discussing why data and how data is important, the basic data concepts, qualitative versus quantitative data, where does big data come from, telling a compelling data story, and roles in data. So before we start out, I would like to hear from every one of us here. Why did you choose the data track? I'd like to know that. So I want you to put your answers in the comment section. Why did you choose the data track? Why data? Why do you think I want to go into data? I want to hear from you people. Thank you. So yes, I'm expecting everyone's input and comments. Why data? Hello. Okay, so Abigail Irefu is saying because it helps to make helps to make an informed decision. Very good. I'm expecting every other comment, please. To make data-driven decisions. Wow. To make data-driven decisions by Olarewaju Victoria. Oladare Damilola says, I chose data because I have a knowledge in data analysis, so I want to learn more of it. Its relation to technology and workspace. Awesome. I just love it. You know, solving problems and also making raw data meaningful. Awesome. By Joanne Fafure. Really awesome. Great stuff. Wow. So I'm expecting more responses, actually. I want to hear from everyone, like, why exactly did you choose data? Because it's important to know your why. It is very important to know your why. Why are you doing what you're doing? In every aspect of your life, you should always know, you should always have a reason for doing what you're doing. So it keeps you committed to that particular thing or that particular task that you're undertaking, right? So if you don't have a good why, if you don't have a strong why, you find yourself defaulting or letting that thing go. But if your reason for doing something is strong, you just get inspired. The fact nobody needs to even wake you up or disturb you. You just want to learn, you want to do more. So that's why your why is very important, your foundation. Why do I want to do this? You have to understand and be convinced that this is why you want to do this. So Victor Akinleye says, for me, I have been working around quantitative and qualitative data since my undergraduate days, also during my master's and ongoing PhD. So I'm here to improve my knowledge and skills on data analytics. Wow, Victor, awesome. Ozezua says, I'm still having issues deciding which track to follow, but because I handle data every time, I decided to choose data above others. Wow, I would like to hear that story. Yeah, let's hear from others first. Okay. I'm in the healthcare industry, thinking seriously of transitioning into data analysis. Chidinma. Wow. Okay. Yeah, so data for healthcare, it's actually, actually very. So for data for healthcare, that's talking big data, because the healthcare industry is really wide. The hospital alone has about 400,000 users. So yes. Awesome. So I'm expecting more responses, but let's move on. So now, what is data? I'm sure based on the information based on what most of us are doing on the chat, it means that we all have like an idea of what data is. So what exactly is this data we've been talking about, right? I'm sure in secondary school or maybe in primary school, we all did computer science. And I remember before I even got into the data field, when they asked me what data was, there was this very popular phrase that we all knew, or at least I knew that was taught to me. What is data? Data is a piece of raw fact, right? So it was just a chant then. I didn't even understand what it was. I mean, like, well, it was like, if anybody asks us, what is data? You just say, oh, data is a piece of raw fact. I don't know if that's what you were taught in your secondary schools or your primary schools, but that was what I was taught. So, and surprisingly, it was not so far from the truth when I got into data. Data is actually a piece of raw fact. Like, it's just data. So what exactly is this data we're talking about, right? Data refers to raw facts and figures that, when processed, can inform and guide decision-making across various sectors. So from the littlest, from every aspect of our lives, in every aspect of our lives, we need data. We work with data, either directly or indirectly. If you wake up this morning and you decide to put on a piece of clothing, it's based on how you feel, right? Your mood, you'll be like, okay, right, how do I feel about myself this morning? The people wear clothes based on their mood. For me personally, I choose my outfit based on my mood. If I'm feeling happy, I will choose my outfit to reflect the fact that I'm happy, which is of course based on data, right? So most people do things either directly or indirectly, from your business to your health to your lifestyle. Data is involved, right? So this piece of facts, this piece of figures actually help you to make decisions, because you can't just make decisions like that. You make decisions based on piece of information or knowledge that you have, right? And of course, those knowledge is data. So data can be collected on any topic and for any purpose, right? It can be used for scientific research, financial analysis and auditing, business management, retail and sales, governance. Like I said, data can be used anywhere, right? From the real world, from the formal world to the informal part of the world. Your lifestyle, your clothing, your hair, everything. In fact, if I'm going to even if I want to make my hair, right? Sometimes I look at a piece of data, okay, what have I seen on Instagram today? What have I seen on a friend? I'm making my hair based on this particular decision. seen this and I like it, so I'm going to make it. I'm using data, I'm using information that I got from somewhere or online to make that decision, right? So that is what data really is. So now, importance of data. As much as we know what data is, we also need to know why it is important. Now, the most definite definition for why data is important is because it's used for analysis. Like that's the basics. If they ask what is it, why is data important? Because it's used for analysis. You use data to analyze, you use data to make decisions. And for you to make decisions, you need to analyze that data first. So other importance of data would be for data-driven decision making. So how does that work? Utilizing data can make strategic decisions and lead to more rational choices. When you use data, you can make more strategic decisions, which can lead you to more rational choices. And with that, you have a higher likelihood of achieving your desired outcome, right? So using data to make decisions allows you to make more rational choices. If you are making choices based on just instincts or based on, without using data, based on instincts, it's always like the likelihood of you coming up with a result that is not up to par is very high. But if you're making decisions based on data, facts, you get a more higher result, you get a desired outcome, you get a better result. Now, you also use data for competitive advantage, right? So effective data utilization allows organizations to stay ahead of market trends, identify new opportunities, understand customer preferences, and outperform competitors, which is very true. So in this world, in this startup world today, most people are doing the same. Most people do the businesses in the same line. Like there's no new business, there's no business that is new. Now, what makes one business better than the other is the fact that they're able to utilize data to make better decisions, right? In terms of market trends, identifying new opportunities, understanding customer preferences, and outperforming competitors. I'm sure all of us know Jumia and we know Konga, right? But if I ask you if you would choose an online marketplace to buy or shop from, what would you choose? Most people will choose Jumia, right? Most people will choose Jumia over Konga, not because Konga is not good, right? But Jumia has been able to utilize data to stay ahead of market trends and also understand their customers' preference, thereby outperforming their competitors. So yeah, that is one advantage of, that's one importance of having data. Then another importance is operational efficiency. Now, as a business person or anybody that likes business or is even working in a business firm or in a business startup as a data person, you need to be able to understand how data helps streamline business operations. Like it is very, very important. If you are in a firm or you're working in a company or you're doing anything and you're working in a company most especially, and you notice that that company is not using data or they're not trying to use data to make decisions or they're not using data to streamline their business operations, then it means that you're in the wrong place. Because in this age and time where data is the new oil, according to that's what I believe. I mean, we all know how AI is now booming and AI comes from data. Data is literally the new oil in the tech world. And there are businesses that don't use data to streamline their operations, then there's something wrong. So data is very important in streamlining business operation and it optimizes resource allocation, right? And at the end of the day, the whole point of using data for this is to have good operational efficiency. So just to optimize operations. Yes, so that's another importance of data. Now, data 101, basic concept of data. So this is just the foundation of understanding data, and it is grouped into the following. Number one, we have data types. Number two is data sources, and number three, data structures. So let's go into data types. Now, data can be categorized into qualitative, which is non-numerical data, or quantitative, which is numerical data. Now, what is qualitative data? So qualitative data can be referred to as descriptive data that you can describe, like, right? It is non-numerical, so meaning it doesn't have to do with numbers. It doesn't necessarily have to be numbers and figures, right? So because it is non-numerical, it can also be known as categorical data. So this kind of data provide insight to opinions, behavior, and experiences, and they are often through open-ended questions or observation. Qualitative data is important as it helps people to decide on how best to record quantitative data. Now, for most of us that are gone through undergraduate and maybe masters, and this slide, the picture here is a questionnaire. For most of us that had to share questionnaires in your undergraduate days, when you were gathering your data, most of the questions you asked like this is just saying, this, for instance, look at this questionnaire on this slide. The store is accessibly located. You can't put 1 or 2 or 3. You just tick a number. But the person that is sharing this questionnaire already has a number ascribed to this list here. So when you're done with your questionnaire, you go back and collate that. So qualitative data helps you to record quantitative data, right? It helps you, and again, it's easier for users to interact with that kind of data because it's more relatable to them than they're giving you numbers and figures, right? So that is the reason why in these days, for those that use questionnaires back in the day when they will tell you to choose between 1 to 10, it's always difficult to choose between 1 to 10. But with this one, it's very, very easy. I agree, I don't agree. It's very easy, right? But if they ask you to choose on a scale of 1 to 10, sometimes it might be difficult because how would you quantify 7 and 8? Like 7, what's the difference between a 7 and an 8? But if I'm saying I agree to something, I strongly agree to this, or I just agree, it is easy to differentiate, right? So qualitative data helps you to understand and translate quantitative data. Now, how do we collect qualitative data? Of course, through surveys, polls, one-on-one interview, focus groups, observation, and questionnaires like this. And now we go to quantitative data. So what is quantitative data? Quantitative data is numerical information, and the numerical data, and they answer questions like how much, how many, how often. So basically, when you're gathering your data, you're just quantifying, you're just giving it numbers, you're adding figures to that data. That is just what quantitative, because it's quantity, right? Quantitative data comes from the word quantity. So it's just adding numbers to your qualitative data. And it focuses on numerical measurement and statistics, right? Yielding more objective and measurable insight. And any information or answers expressed through number is quantitative data. Any information you gather through numbers is quantitative data. For instance, health record or revenue amounts, they're all quantitative data. So the next one we'll be going into is data sources. So where do we get data from? Where can we get data from? Data can be collected from various sources, but we have surveys, of course, like I said, you can get data from surveys, you can get data from government websites. If you want to know the data, if you want to get statistics on the population of the number of people in the country, go to the government website. Or if you want to get information on any information on that particular country, you go to that company's website, right? You will definitely see sites that links you to website that you can get their data from. They also have online platforms like cargo.com. So on cargo.com, you can see a lot of data sets where you can work on, from health data to finance data, to customer data, to sales data, any type of data, even to government data. You can find that on cargo.com too. And then the third one is data structures. Now, data structures can be categorized into structured data and unstructured data. Unstructured data is what's known as organized data. And these are data that you can fit into your data tables, right? So such as your numbers, text, dates, etc. Anything that can fit into data table, like on Excel, you can be able to fit all of this data into data tables. They're known as structured data. But unstructured data or unorganized data are data that you can't fit into data tables, like your audio or video files, right? You can't fit them into data tables. So yeah, unstructured data. And one of the reasons why you have to fit data into data tables is because it helps you for easy analysis. So if you cannot fit the data into data tables, you can't easily analyze that data. Now, with all of this, with all the whole data we're talking about, it's one thing for you to know data, right? It's one thing for you to be able to even analyze data. It's another thing for you to be able to tell a story with data, right? So no stakeholder, nobody, in fact, no layman, let me use the word layman. We'll call them non-technical stakeholders, anybody that is not technical, right? No non-technical stakeholder wants to see your raw data. They don't really care about that. They want to see the results of that data, right? And the only way you can show them the result is by telling a story with that data. So if you're just telling them a story that, 20% of people, I just use your mouth to explain what your result is, nobody would hold you to that. But you're showing them based on facts, you're showing them using visualization, for instance, you're telling them, this is the range, this is how I analyze my data, and you're telling a story with your data, it sticks more. Just like how when you're trying to explain something to somebody and you use storytelling, right? It sticks more with that person than when you're just quoting figures and quoting numbers. Yes. So what is data storytelling? Data storytelling is about crafting a narrative from your data. It often comprises both of written or verbal story, as well as data visualization, descriptive imagery, or even video materials. Yes, you can change that. You can change your data to video for people that you believe would need that kind of material. Like we need that kind of material to understand what you're trying to pass across to them. So there are all kinds of applications for data storytelling, from talking through a dashboard on a weekly team meeting to building a case for a major new initiative with your leadership team or board. No matter how routine or simple, the act of crafting a compelling narrative from the numbers can be the difference between winning the room or losing it completely. And also, when I started out, I said something and I said that data is important and you can use it in every aspect of your life. Even if you're not a data person, right? Understanding data helps you to pass your message across, right? People would listen to you more when you're using facts and figures to talk about things, right? Even in this age and time, if you're telling me that, oh, this is the reason why I shouldn't do something, and you're not telling me that thing with facts or figures, like why exactly are you telling me not to do a particular thing when you don't have a statistic to prove what you're saying or what you're saying, right? So most people will tell you, oh, you don't have facts, then I cannot listen to you. It is normal. It is very, very common. So having facts and figures is actually a determinant to winning a room or losing it. But now imagine that you can pass these facts and figures with a story that captivates your audience or captivates the person you're trying to convince. Then that's a win for you. So that is the importance and the how data storytelling helps you convey your message. Now, this is a dashboard, right? This is a dashboard. Anybody that sees this dashboard, even if you're not a data person, you'll be able to draw inference from this. Seeing this dashboard, if you're not a data person, you'll be able to draw inference from this. So I don't need to come and start explaining that this one and that. I don't need to even start speaking too much English. All I need is this dashboard, and I say this dashboard is for the CFO, right? It's the CFO of the company, and CFO means Chief Financial Officer. So it's saying that for that particular month, their net sales was $4,609, and they made a 20% increase from their previous month, meaning they had a 20% increase in sales from the previous month, and that monthly sales for the sales for that month is 4,609. This is also telling you gross margin. We have net profit. We have expenses, a pie chart showing expenses. We have a bar chart showing expenses versus income. This is telling a story already without you having to even talk too much. So this is what data storytelling helps us achieve. Now, how do you tell a compelling data story? The first thing to do is to explore. You need to explore by uncovering patterns, trends, and insights hidden within data. So when you're given a piece of data, the first thing you need to ask yourself is, what exactly am I deriving from this? What exactly am I deriving from this data? And the person who's sending you that data, or whoever is giving you that data, would have given you some instruction on what he wants to use that data for. So based on that instruction, based on that conversation you've had with the person, you're able to uncover that pattern, trend, insight with that data, because you don't just use data cannot just be there for no reason. People collect data for reasons, and if they're going to analyze the data, because of that particular reason. So based on that reason, you'll be able to now say, okay, this is it. I want to uncover the patterns, the trends, and the hidden insight within the data. And then when you're even analyzing the data, you might see some things that you can infer from that data, minus what the person had, minus what you were initially working on, right? You could see some other insight that you can derive from that data. So being able to uncover patterns, read between the lines, or gain insights from data is a huge skill. It's a huge skill on its own. And the second thing is to ideate. What does ideate mean? Brainstorm. So you've already uncovered the pattern. You've seen, okay, I can do this and this. I can put this 2 and 2 together to give me this, right? You now ask yourself, how do I make this, how do I do this in a creative way? How do I present this data in a creative way? Should I use a chart, a pie chart, a bar chart? Like, how exactly will I present it to people for them to understand what I'm saying, right? For it to make sense to them at first glance, right? How do I convey this message? That's what ideating. That's where ideating comes from. You brainstorm and you develop creative ways to present the data's narrative. Then the third thing to do is to communicate. So effectively communicating conveys the data significance and impact through compelling visuals and narratives. So when you're able to effectively convey your data significance, like the importance of your data, it impacts, and you can impact and create a compelling visual or narrative. You can create a compelling visual, like people will be able to remember all the things you presented based on your data because you're able to communicate effectively. And then the last thing to do is to strategize. So based on that data, after you've done everything, you have to strategize based on the data. You have to leverage the insight you got from that data to now make decisions. So wanted to get to present your data. It's another thing. The next thing you have to do after presenting that data is to say, okay, based on this data, what exactly are we doing from here? What is the result? What is this result going to help us achieve? Right? So you use that, you leverage data insights to make informed decisions and drive impactful solutions. So that's why data is one of the most important data is one of the most important thing in every organization, in every government, in every sector and aspect of, in fact, our lives, right? So it helps you make this decision, it helps you drive impact, helps you help you with impactful solutions. And you can only do that with data. And it's one of the interesting things in every aspect of the tech space. They can't do without using data, from products to software to design to, if I just name it. In fact, every aspect of a company can't do without data. And let's say, giving an instance in product design, for instance, there's one thing they call user research. You can't do user research without data, right? You're going out to your user to find out how they would accept a particular product or their insight on a particular product. When you get that information from the user, you have to analyze that information to be able to make decisions based on that product you're trying to build or the product you've built already, right? That's user research. So of course it is data. So every aspect of a company needs data. They cannot do without data. Now, we're going to be talking about the roles in the data ecosystem. Everybody was saying, yes, there's this thing, when I started out in the data world, right, I knew that the first thing is the most natural thing to be a data analyst. But most people didn't really understand what everybody then thought that being a data analyst was it, right? What's a data analyst? Yeah, cool. That was all. But knowing what other roles did from like data science, you have data science, machine learning, AI. Data engineering was not that popular at that time. So we had the business analyst, marketing, and you had what's this? Everything is, you think it's all all different streams, right? But it is not as complex as it is. Data analysts, we have different roles in data, and the beautiful thing about data is, as you go in these roles, as you develop your skills in these roles, you get a sense of growth. So for me, when I learned data analysis, and I decided, okay, I wanted to do data science for a bit, it felt like I was growing, right? But because I was adding to my stack, I had to learn new tools, new technologies to become a data scientist. And I had to also learn new technologies to become a data engineer. So I had to add to my knowledge. And as I added to my knowledge, I was growing. But compared to software engineering, right, to me at that time, compared to software engineering, if I was a front-end engineer, for instance, I need to know HTML, CSS, and JavaScript, right? So if tomorrow I decide I want to learn Bootstrap and Tailwind, it doesn't change the fact that I'm a software engineer, a front-end developer, right? It doesn't change that. It's just I'm adding more knowledge to my stack. It doesn't change anything. It doesn't move anything for me. But for data, you just get that sense of growth that, oh, I was a data analyst, but now I'm doing data science. Now I'm doing data engineering. Tomorrow you could decide I want to do business analysis. Like, you just know that you've grown. You just feel that sense of growth with data. So what do data analysts do? They are concerned with analyzing and interpreting historical data to gain insights. And what does all of this mean? Data analysis deal with data that's already existing, right? So data analysts cannot, of course, data has to be exist for you to analyze. But the difference between data analysis and data scientists are data analysts, they deal with data that is already existing. While data scientists use the data that's already existing to derive prediction. So they're able to use data that's already existing to predict what will happen in the future. That's the difference between data analysis and data science. So why data analysis will stop at just using that data, interpreting the data they have currently to just gain insight. Data scientists will take that further to now develop predictive models that would help them make predictions for future events, right? Or what we call forecasting. That's what we call forecasting in the data science world. You have to use it for forecasting. Then you also have, using machine learning algorithms, you use that for forecasting, right? That is basically the difference between a data analyst and a data scientist. So, like I said, data analysts are concerned with historical data to gain insight, why data scientists, they develop and deploy predictive models, machine learning algorithms, and data visualization to solve business problems. So they use the core of a data scientist is to be able to predict what will happen based on the data that's already available. That is their main focus, prediction. So giving you a typical example, in a workspace, if I am a sales analyst, for instance, and my company, you know how companies will just come up and say, oh, they have a target for this particular month, they want to hit sales target, say maybe $4,000 sales target, and their previous month sales was say 2,000, and they want to increase it to 4,000 for this month. Right? It's one thing for a CEO to wake up and say, yes, this is what the target I want to hit. It's another thing to now analyze the reality of hitting that target, right? Or because all of those things, why you want to set a target, you need to balance it with the reality of things. So what a data analyst will just do is, okay, based on the what a data analyst will do is at the end of that month that they want to target 4,000, they'll just pick the data and just analyze anything they see, anything you see there. That is the end. If it's not up to 4,000, they cannot kill themselves because that's what the data is saying. But as a data scientist, what you do is you pick past data from the company or sales records from the company. You use to analyze trends, like, okay, what exactly are the trends? When do we sell the most? Or in like what days do we sell the most? How does our sales trend move? What does the sales trend say? So based on that information, they're able to now predict that if we are able to do this and this and this, we can hit 4,000. Right? So based on that, we're not able to present their findings to the company. Okay, so we realize that on Fridays, Saturdays, Sundays, we make more sales, right, compared to Monday and Tuesday. And then on Wednesday and Thursday, we also do this and that. So if we can find a way to get more people to buy from within those periods, right, and also get ready to increase our goods and cost, the goods available, right, to meet that demand, we can hit these targets, of course, based on prediction. So with that, they are now able to target maybe sales marketing can say, okay, we're going to target marketing campaign for Fridays, Saturdays, and Sundays, so that there will be more to gain more customers. People in charge of production can say, okay, we're going to increase our production to so and so percent to meet demand for this particular product. So that's how decisions will now start forming, just to get to that target based on what the data scientists have been able to predict. Yes, so that's the difference between an analyst and a scientist. Now for data engineers, I call data engineers the operation guys of the data world. Because without data engineers, all these things that we are saying, all this whole data, it would not in quote unquote, it will not come to fruition, right? So these days, the whole world, our world has gone to social media, app. A lot of things are now going web, whether it's a web app or a mobile app. And all of the information that you gather with this medium, from web apps to mobile apps, are stored on what we call a database. Now, and a data analyst cannot have access to the database. Neither can because the database is like a warehouse, and not anybody can go. There's only the person that owns the warehouse or that built the warehouse that can give you permission to go there. And because of the sensitivity of data, they can't just allow people to just persons to just go there. So what they do is, what a data engineer will now do is they will create a pipeline from that warehouse to where other people can pick that data up from and use it, so that the initial warehouse will be safe. They will now create a pipeline to another warehouse that can be used by others. So even if anything happens in that way, in the second warehouse that they've created, the main warehouse would still be intact, right? The main warehouse will still be intact. Yes, so that is what data engineers mostly do. They create pipelines, they manage data warehouses, they help with effective storage and processing of data. They also do data management. And all of this is called managing of the data infrastructure. We are managing the whole infrastructure, the operational work or the operational workload of data, of ensuring that data goes from one source to another source. That's what data engineers do. And honestly, I think I'm going to share this story at the end of this to show you how I moved from being a data analyst to being a data engineer. Right. So it's pretty. So I can hear my voice is echoing. Please, is there anybody on? Okay, that stopped. So yeah, it's actually fulfilling, like every aspect of whatever work you want to do, whether it's from data analysis or data science. Of course, you find fulfillment. But for me, because I've tried everything, I just love data engineering, and maybe it's because of the kind of person. It has to do with my personality. So anyways, so yes, I always love doing hard things. So I love doing hard things, and data engineering, like I said, is like operations. So if you have worked in operations before, you know how difficult operations can be. So, and maybe because I love doing hard things, that's why I stuck with data engineering. Now, the last but not the least are the business analysts or the business intelligence analysts. And these are the people I call the product managers of data, right? So now there are some persons that, like I said, you have to be able to compare, you have to be able to tell a story with data. But most data analysts, they don't really have that that skill, right, to make a compelling story. Not everybody has that skill to tell stories with their work. Not everybody has that skill. But as a data analyst, you should be able to manage that. You should be able to tell a story. Of course, you're able to derive insight from your data, but also tell a story. So most business analysts. So most business analysts, right, they help to tell a compelling story with their data, and they also help. They're also the ones in charge of non-technical stakeholders in companies. They work with them, just like the product managers will work with the technical and the non-technical guys. It's the same way business analysts work with the data analysts, data scientists on the team, and they also work with the non-technical stakeholders. So that's why I call them the product managers of the data world, right? So they understand the data, and they're also able to like convey that message to people that do not understand the data effectively. Now we have other roles in the data ecosystem. We have the marketing analysts, of course, they deal with marketing data. We have supply chain analysts that deal with supply chain data. We have financial analysts that deals with finance data. We have sales analysts that deals with sales data. We have customer success analysts that deals with customer data. And so much more. There are a lot of data roles. Like like I said, with the way data is going now, a lot of roles, we have a lot of data. A lot of schools, we have a lot of data. We need a lot of data analysts. HR analysts. There's inventory analysts, there is even product analysts. Yes, for product guys, that we have product analysts, because you need an analyst to be able to do, like what I just gave you the example of user research. They need to analyze that data to help inform the decisions on how they would build the product. So if I decide to do a user, if a non-technical person or someone that's not an analyst goes for user research, they can't, if they don't have somebody on the team that understands how to analyze data, they won't be able to change that data to what? Insightful information that will help them in making decisions. So they will need a product analyst that understands products and also understands analysis to be able to solve that. So these days, there are a lot of data roles, and there will be more, because data is the new oil in tech. Data is here to stay. So yes. Now, this comes to my best part. Tools for data analysis. The first and the most important tool for data analysis is, which is also like very easy to learn, is Excel or Google Sheet. Everybody knows Microsoft Excel and everybody knows Google Sheet, right? Of course, if you're going to learn, I'll advise you to use Excel, because if you can use Excel very well, then you can use Google Sheet, because they are both similar. It's just that Excel has a lot more functionalities than Google Sheet will have. But the advantage of Excel over Google Sheet is that Google Sheet has a better UI. Like, the user experience is better. And then this online thing, I've not used Excel in a long time. Since I found Google Sheets, I've not used Excel in a long time. So, but the last time I used Excel, there was not this online, being able to share your information, like share your sheets or share your Google Sheets with somebody else was not on Excel. Although I heard that, I found out recently that they've implemented that since, in fact. So yeah, that's good for them. But if you're going to learn, like I said, learn with Excel, because once you learn with Excel, it helps you understand Google Sheets. You can just easily do that. So the first thing is to learn is Google Sheets. Now, most people make mistakes of learning other tools. Like some people will learn Python, for instance, before learning Excel. Now, it doesn't mean that it's not good though. You can learn Python. But what it will do to you is that, because you already know how to use Python, when it comes to data cleaning, of course, when you want to do so there's some intricate aspects of dealing with data that you would need to. When you don't understand it in the basic level, understanding the importance at that Python level, when you're using like a very high-end skill, would be it should just be like, you won't really get it, right? So you'll be doing it, but you won't understand some important things that you need to look out for, right? For instance, if you're using Excel to clean the data, there are a lot of things that you can, and of course it's easy. There are a lot of things that you'll be able to easily identify. You can do your filtering, you can do your conditional statements, you can check for duplicates, you can do a lot of things. Of course, you can also do all of these things with Python. I'm not saying you can't do them with Python, but because Excel, you see the data as you are doing it, so you're able to see that, oh yes, I'm progressing with this thing. But with Excel, you just have to write code. You write code. You don't know whether your data is how the thing is, how you are seeing, what it will look like in the back end. You're just writing code and you are telling you that yes, it has gone, whether the code is running or not. You're just seeing it like, okay, yes, you've done everything the code for this, you've written the code for this particular task, everything for this particular task. But with Excel, because you've already seen it you have seen the pictorial form of it, how it works. So when you get to Python, it's easy for you to also picture what's happening at the back end and what is it doing for your data. Do you understand what I'm saying? Or should I go over it again? Hello, can you hear me? Please, I want responses. Should I go
hear you.
Or do you
We can
understand?
hear you.
Okay.
Yeah, I think we understand what you're saying is Excel is there's visual. You are seeing what you are doing. The visual, whatever you are doing is showing instantly. But Python, since it's a way of writing codes, it's only when you are finished and you go to preview it or something before you launch it before you see the work that you have done.
Exactly. That is it. So, and we also get a sense of okay, fulfillment, like, okay, I've done this work, I'm seeing the progress, and I see what it will look like at the end of the day. But with Python, you would have finished doing everything, and then when you preview, you find out that I didn't do this particular thing, right? You have to now go back again and make some adjustments. So yes, of course, Python has a very huge advantage, which I will discuss when I get there. But understanding Excel helps you, like, it's like learning how to write ABC, right? But when you learn Python or when you learn other tools first, it's like you're jumping to writing letters when you don't even know how to write ABC. So that's how it works. Okay, somebody saying anything? Okay, so the next tool in data analysis is SQL, that is structured query language. And of course, SQL also does the same thing that Excel will do, but you'll be writing queries instead. You'll be writing what we call queries. So it's like, it's a little bit like code, but it's not also like code, right? But this is, of course, you're writing code, you're writing queries to analyze data. So there are different platforms for SQL. We have MySQL, we have PostgreSQL. There are like a lot of SQL platforms that you can use. Then the next thing is data visualization. This is what you use to visualize your data. That dashboard I showed you is data visualization. And the tools that you use with data visualization, we have Power BI for Microsoft, we have Tableau from IBM, we have Google Looker from Google, right? We have a lot of visualization tools now. So you can make a research, but like I would say, understanding Power BI and Tableau will help you understand others. Once you know Power BI, you know Tableau, right? You can, any visualization tool you see in this world, you can use it. Now coming to Python. All of these things that what Excel will do, SQL will do, data visualization will do, Python can do everything, right? But like I said, all of this Excel, SQL, and data visualization will give you foundation. You get to understand what Python is doing for you, right? Because you didn't know the intricacies behind all of this, like behind what you're doing. You didn't know the intricacies behind your work, right? So using Python is like a soft landing, and it's easier to relate to what you're using Python for. But imagine you pick up your data and you just want to analyze with Python, and you've not used other tools. Yes, because of course you have learned Python and you have learned how to use Python. But if you don't know, if you have not done it, if you have not had a background knowledge of these things, it will be difficult for you to like visualize what is going on. So I had friends then that did data science. Of course, when you're doing data science, you have to learn Python. So I had friends that did data science and they learned Python without learning all of these things. They had to still go back to learn Excel and learn SQL because they found out that because they didn't understand the basis, right? It was difficult for them to, like I explained, so because difficult for them to visualize what they were doing in their head, why they are using their code to write it out. So most of them had to go back to learn all of this. Plus, Excel, SQL, and data visualization gives you a better foundation. Like, okay, this is the foundation. Like, you already know. Like, when you learn these three things, the first three, yeah, you can work anywhere as a data analyst. You know Excel very well. You know SQL. You know data visualization. You know how to tell your story with that. Then you can start working as a data analyst. Those are the three important tools you need. Then with Python, when you add Python, of course, you're not going to data science. We also use Python in data engineering, right? We also use R. R is for statistical data. R is for statistical data, and they use that one in the educational world. So instead of using Python, Python is used in the organizational world. R is used in the educational world, but they do the same thing, right? So most education is like people that are doing their PhD. I'm sure there's a guy that said he's doing his I've done his master, he's doing his PhD. I'm sure you can relate to this. He used more of R than Python. So people in the academia, they always use R than Python for analysis. And so those are the most important, in fact, those are the tools you need. Of course, for data engineering, for instance, apart from just all of this, you need to also learn other things, like you need to know cloud development. You have to, because you're going to be storing your data in the cloud. So you need to understand how cloud development, creating pipelines to clouds works, how all of that implementation works, right? How you store your data in data warehouses in the cloud. So you need to understand cloud development very, very well. So yes. So that is all on tools for data analysis. So please, do we have questions? If you have your questions, please put them in the Slido. I'll be taking questions. If you have questions, put them in Slido. So I'm waiting for your questions, everyone.
Please, everyone, let's ask our question. The link to Slido is on the chat box. So please, let's write out our questions there. You can send it anonymously too as well. We're expecting questions. Hi, Doreen. I think we have questions there. Should I go ahead and ask, or you do that from your end?
Yes, please do. Thank you very much. Thank you. Please do.
All right. So one of the questions says, at what point do you get to choose a niche from the beginning or at any point? Like, okay, as a data analyst, like at what point do you choose a niche? Maybe the person is trying to say, okay, a data analyst, a data engineer, a data scientist, a business intelligence analyst, sales analyst. I hope you got the
Yes,
question, ma'am.
yes, I understand the question. So for that, I think you would choose a niche based on your interest, right? Right. Um, Using myself as an example, when I started out as a customer success analyst because I was working in the customer success space. So I was working then as a customer support person. Like I was answering calls, so I understood customers a lot. So when I started data, I just it was easy. It made sense for me to work as a customer success analyst, and from there, I graduated into being a data analyst. Right. So the difference between a customer success analyst and a data analyst is that while a customer service analyst would focus mainly on customers' data, a data analyst can do all type of data. So if you give me a marketing data, I can analyze it for you. If you give me financial data, I can analyze it. If you give me any data at all, you're able to analyze it. But at that time, because I didn't have the knowledge that would help me to make that kind of decision. Because I also had experience in customer success, right, and customer support, and I understood customers' behavior well. It was easy for me to just be a customer success analyst. So yes, it's based on your interest. You can start out as a data analyst. It's just your willingness to learn and to grow that matters. Your willingness to learn and to grow. Thank you, and thank you very much. The person that asked that question is a very good one. Thank you for that.
All right, thank you so much. Okay, so another question: how many months of learning these skills were you able to secure a job?
Interesting. So yes, like I mentioned earlier, I was working in the customer success space, right? I was working in the customer success space. So I had started learning. So I was working in the customer success space, and it got to a point where we needed to solve a problem we needed to solve a problem in my company, and we had data, but we didn't know how to utilize that data. So I had to go and learn, like, okay, what are we going to do? Like, how am I going to solve this problem? I had friends then that were also like in the data world, though they were doing like bigger things in data, like data science. So I asked them questions, and they told me, go and learn this, go and learn this, go and learn this. I think I learned data. I learned data, everything that relates to data in about 2 months, right? I learned Excel, I learned SQL, and I learned visualization. Well, like I would say, like I would always advise people, please start with the basics. You just need to be able to solve problem with data. You don't need to know everything. In fact, you cannot even know everything. Even myself, I don't know everything in data. If you give me something to solve on Excel, I'll still go back to Google to go and search out what to do. But because I already have basic knowledge, right? It's easy for me to ask questions, use that question to now make decisions on how I want to solve a particular problem, right? So I might forget, I would have forgotten most of that. I definitely would have forgotten most of the formulas or functions I would need to solve a problem in Excel, or most of the queries I would need to solve a problem with SQL, right? Or even most of the tools on Power BI. But I mean, the world of internet is not here for fancy. So you can always go back to like refresh your knowledge. But because you already have that understanding, you've worked with it before, so it's easy, right? So for that particular question, I would say that just start. That is it.
All right, thank you so much. So just start. All right, another question. Good evening. My question is on which tool is good to start with on learning as a novice or a new learner?
So you start with Excel. Please. In fact, I'm pleading with you. Start with Excel. Then from Excel, you graduate to SQL. From SQL, you go to visualization. Once you have works to prove those three, then you create your portfolio and start applying for jobs. You learn the rest on the job. That is it. You learn the rest. In fact, there are some things you didn't learn when you were learning. There are some things you didn't even know when you were learning. Like you have to go and find out because of your job. So when you know Excel and you're able to solve problem with Excel, you know SQL, you're able to solve problem with SQL, you know visualization, you're able to solve problem with visualization. I would advise that you can create your portfolio, put those works you've done on all of those three tools together, and then start looking for a job. Yes. And of course,
Okay.
LinkedIn.
All right.
LinkedIn is all else.
Okay, thank you. How can we track her data and ensure it's not stolen from the internet without our consent? Can you hear
Wow.
me, please?
Yes, I heard you. How can we
All
track our
right.
data and ensure it's not stolen from the internet? Wow, that's a great one. I think that's where data encryption comes in. Like that's a very big word, and that's where data engineering comes in. So there's what we call data encryption, right? Encrypting your data is how you can prevent your data from being hacked, right? And also creating a warehouse. In fact, your data must be encrypted, your warehouse must be encrypted because anything can happen. You're storing most data are stored in the cloud, right? Unless your company has money to buy to build their own server, to keep their data in the company, e.g., companies like Facebook, right? Companies like Google, they can't, they don't, in fact, Google will definitely not even have a cloud because they own a cloud service in themselves. So they have servers where they store their data. So for companies like that, you can't be scared of your data being leaked or your data being stolen because they have their servers. Their servers are in-house. But for small startups, I mean, you are going to be using cloud services. So the best way to prevent your data from being stolen is by encrypting your data. And that is a whole world on its own. So yes, that's it.
Okay. Thank you so much for that. Okay. Another question here. How can we trust the data we are getting as the data can be manipulated and unreliable? So how can we trust this data that we are getting? Like, since data
Yeah,
can be manipulated and unreliable.
yes. So there's when you start learning data, there are some key things you be taught, and one of that is data integrity. Of course, whatever data, because that data will help you make information, will help you make decisions, right? So when you want, for instance, you want to analyze the data, 1,000 data. Not all that data would not be correct. Some people might not feel some information, or they might even feel wrong information, right? But a majority would not feel wrong information. I'm just even saying, but let's even assume everybody decides to feel wrong information. It's based on what you have that you can work with. You cannot manufacture data from anywhere. So how can you trust? So can I get that question again? How can you trust?
Okay, I'm coming. Okay. How can we trust the data we are getting as the data can be manipulated and unreliable?
Okay, yes. So you have to. There's what we call data integrity, like I said. So there's a whole roadmap around data integrity that you have to follow, right? So when you're analyzing your data, when you're doing what we call data cleaning, right, you have to ensure that the quality of your data is up to par. And there are like a lot of roadmaps you use, a lot of things you check for. So if your data has what we call outliers, at the end of the day, when you have a data that has like over 50% outliers, then you know that that data is warped. You have to like clean it, like you have to trash it and get another data from maybe somewhere else. So when you're done, part of what you do with analysis is checking for outliers. So when you have like outliers, and then based on whatever outlier you're looking at, maybe it might not even be the whole data set that will be worked. It might be just a particular one. For instance, if I want to get health information of people that have HIV, God for instance, they wouldn't want to share that, oh, they have HIV. So they would lie about it, right? Or you even use a general one. People that have like maybe STDs, they might not want to share that kind of information with you. So they will just lie about it. So imagine that my data is to know the number of people that are actually battling STDs. And then I go and ask people, and people are lying about that information. You won't be able to get correct data, right? So to solve that, one of the ways you can find that out is just some questions you have to ask in that data that will be leading. So it's like we call it leading questions. So you cannot just ask people, do you have STDs? They will tell you no. Even if they have, they'll tell you no. You have to ask questions that would be able to like help you get to where you're going to. So those leading questions, imagine that that's why there's some questions you will ask. There's some surveys you will feel that they'll be asking you, oh, do you do this? They will just asking you leading questions. You notice that the question is leading to a particular point. They might not even ask you do you have STDs directly, but with the questions they're asking you, the person that is setting the question or the data question will be able to use to infer where it's going to based on the question it's asking. Do you understand? So that's another way we can also like prevent that or mitigate that. Yes. Victoria.
Can I continue for her?
Please do. Thank you very much. my laptop, I can't access the slide. I don't know what's going on. So please do.
Okay. How many months of learning these skills were you able to secure a job? I think they've asked that.
Yes.
Okay. At what point do you get to choose a niche? They've asked that. Good evening, ma'am. My question is on which tool is good to start. They've asked that. How can we start? They've asked that. How can we track our data? How can we
Okay,
track our
sorry, my network kicked me out. So let me continue, please. Thank you.
Okay.
All right. Okay,
Thank you.
so the next question, I don't know statistics and accounting, but I am interested in becoming a data analyst. Can I succeed?
Wow. You can. In fact, you will. As long as you will succeed. Like I said, it's just your quest for knowledge. You don't have to know everything. You don't need to know everything. You just need to know the basics, right? And the more you grow, you learn. As far as like I said, that's what I was asking. That's why I asked the question, what is your why? If you have a very strong why, you want, and in fact, you don't even need to even learn. The person that says she doesn't know accounting and statistics, you can decide that instead of me doing everything, I want to just focus on financial analysis, right? You could, I mean, you will go really far being a financial analyst, because financial analysis is not just about just the analysis part. You have to understand finance itself. So imagine that you go and learn finance, and then you also know how to analyze data using finance. You're able to build financial models. These are what companies use in making decisions about money, about growth. You can work anywhere. Work with venture capitals. Work with investment companies like PwC. We have all these top four: KPMG, PwC. Being a financial analyst, you can work with any one of them, right? So but you don't even have to have a foundation. You don't need to have a foundation, right? In accounting. You don't need to have that zeal to learn. There are a lot of courses online these days that you can learn anything related to finance. Go and take a quick course on finance. You didn't know the analysis already. You know analysis. Well, now you now need to learn. Once you've learned analysis, that's the one part. You can go and learn finance. You now find questions or problems that now bring the two of them together. Because you need to know both. You need to know both finance and analysis at the same time. Then you can now start using the both of them to do whatever you want to do. So yes, you can. You can do anything. You don't even. I don't even know statistics to myself. I didn't know statistics when I started out, but I had to learn statistics along the way when I started doing data science. So you can. You can. Yes.
All right. Thank you so much for that. I think we have an interesting question here. The person
Okay.
asks that, okay, you are passionate about girls in tech. Will you be passionate to help a guy like me learn tech?
Okay. So I'm going to okay, so let me be fair, yeah. The reason why I'm passionate about women in tech is that it's just like engineering. To give you a background, I studied petroleum engineering in school. So I understand how limited or how limited women are in these spaces. Tech, engineering, it's very, very limited, right? So in my department, we are like, I think we had like about 50, we're about 50 or close to 50. We had about 3 ladies just in my department. Now, imagine it across a faculty. Like, so, and also it's also like that in the tech. So my passion for women in tech is just to get more women into tech. Most people women think that tech is hard. It's not hard. It is not hard, right? So that's what it's about. As a guy, of course, I mean, I'm here. I'm open to learning, to teaching everybody that needs to learn. But I'm more passionate about ensuring that women understand that whatever they set their mind to, they can do it. Like, they're not small now. Women are not small. So whatever we want to do, if anybody decide that it's software engineering she wants to do, to give you to even like buttress that, I'm currently learning software engineering. I'm a data engineer, but I'm currently learning software engineering. Right? I'm doing both front end and back end. So you can do anything you want to do. For ladies, I'm just saying this to the ladies, right? So, but as a guy, of course, you can also do whatever you want to do. Anything you want to do, but we're all here for it. Both ladies and guys, you can do whatever you want to do.
Wow. This
Yes.
is this is motivating and challenging. You can do what you want to do. Women supporting women.
That's
Okay.
it.
So, all right. I am interested in becoming a data analyst. Please, can you mentor me? This is shooting
Oh
your shot.
yes. Yes, I definitely can. I have a mentor, a mentee group that I work with currently. So yes, you can join that. But like I said, I would interview you. So if you're ready, and I also don't like slackers, right? I don't like slackers. I don't like people that are not ready to do the work. So it's one thing for you to want to learn, it's another thing for you to be able to do the work. I won't be able to teach you everything. I can only guide you, right? So you have to be ready to do the work based on my guidance. And if I'm setting targets for you, you should be able to accomplish it without, in fact, without what excuses, because that's what will help you even in the workspace. Your manager or whoever cannot tell you to do something, then you tell him after the deadline that, sir, I did not do this thing because of so and so. Not possible, right? Even with your assignments in school. So yes, I'm open to doing that, but you have to be ready to do the work.
Okay. So how do we get a? Okay, I think we'll talk
Okay,
about
for that,
different.
I'll drop my LinkedIn. I'll drop my LinkedIn name, so you
All
can
right.
just find me on LinkedIn, and we'll go from there.
Okay. Okay. Thank you, ma. Okay. So another question: what are the key software one needs to develop to become a skilled data analyst? I think this has been answered, right?
Yes.
Okay. Thank you, ma'am. All right. So, how is video unstructured data? It shows visual. Like you gave us two types of data types. That's you know, structured data and unstructured data structures rather. So this person wants to know that how is video unstructured data? By why do we
Oh, okay.
categorize video as an unstructured data?
Hmm. Interesting question. So, like I mentioned, structured data are data that you can put on a data table, right? Data you can put on data tables. I'm sure you've even if you've not used Excel before, I'm sure you know how Excel is form is how the way Excel works or how it looks or what it looks like. We have rows and we have columns, right? So of course you can't load a video on Excel because that is one of the ways you analyze. You cannot analyze that particular kind of data. The only thing you can get from that kind of data is inference. So if you watch a video, for instance, you can able to use that video. You're able to use that video to bring out information or data from that video, but you cannot analyze that video. You can't take that video to Excel and say you want to analyze it, or take it to SQL and analyze, or take it to even Python. You can't, right? So you have to just gather data from that. Of course, you can. I might decide I want to do an interview and I go record. Maybe I want to interview people on a particular topic, right? I can do a video recording of that of people. But when I'm done with that, I cannot take that video and put it on Excel or whatever platform I want to use to analyze. I have to go again, watch that video, gather, bring out the information or the data from that video, then put them on a table format and then analyze that based on the video. So yes, of course, that video is a data, is data too, but I can analyze that video. I have to bring it out, gather, use that video to like get my data and then analyze that based on what the video has said. Do you understand?
Okay, yes,
So yes,
ma'am.
that's that. Yes.
All right, thank you, ma. Okay, someone asked a question. Okay, someone asked, can I get your contact, please? Mr. Is it Miss or Mrs. Please?
Miss.
Miss. Okay, thank you, Miss Doreen.
Yeah, so I
She
dropped my
has.
LinkedIn on
You
the
can
chat
check
box. So please
the
follow me
chat box.
on LinkedIn and
So
send me a message.
our LinkedIn is here. Just send an him.
Yeah.
Just connect. All right. So another question said, "Ma, I didn't get the difference you gave between data analysis and data science."
Oh, okay. So I said data analysts. Data analyst works on historical data. So they work on data that is already existing, right? Let me use an instance. Say you work in a sales company, right? Like the example I used, you work in a sales company and you want to gather you want to gather information. Let me even give you a typical work scenario, right? Your CEO comes one morning or the beginning of the month and sets a sales target. That's what, of course, all companies do that. Say, oh, this target for this month is so amount. Say, for instance, the target for this month is say $4,000. Your CEO comes to the company and says your target for this month is $4,000, right? Everybody does their work. They try to meet the target. What a data analyst will do in that case is once the month ends, she'll carry the information that they've got. Finance people will send their data. Marketing will send the one they use to ensure that they got people that will buy the product. They will all send the data, and based on that data, they're able to infer that okay, we're able to meet social targets based on the number of customers, right? And based on the number of products that we had to sell, based on this and that. So she's working on data that is available, right? But a data scientist, what a data scientist can do is, if your CEO comes and says we want to meet a target of 4,000, what a data scientist will do is, based on past data from previous months of transaction, They will carry data from previous months, analyze that data, find trends and patterns in that data, from sales patterns to marketing patterns to all, in fact, all aspects that all patterns that would lead to ensuring that we meet a 4,000 target. They will get that pattern. Using that pattern, they will now make predictions that, okay, we want to hit 4,000. If the last month we did 2,000, of course, if we did 2,000 last month, we want to be able to do times 2, right, of that this month. We have to do some things. So based on the data they've had before in the past, you're able to analyze and say, okay, I'm giving an instance that this is a real work scenario. This is something that's happened. So you give an instance, you say, okay, based on my data, I'm able to see that what we make more sales on Fridays and Saturdays because it's the weekend, right? Mondays and Tuesdays are usually slow. Wednesdays and Thursdays are in between. But Fridays and Saturdays are the most. So what we can do is we can target our marketing campaigns, our ads and everything to Fridays and Saturdays, push for more customers within those days, right? Also, whatever promotion or whatever I want to do should be targeted within those days so that it's able to reach more customers and customers are compelled to buy Fridays and Saturdays because that's when we have most data. But of course, one thing for you to have customers, it's another thing for you to be able to meet that demand. So you also be able to analyze that based on what we do today, production can be able to increase their production number if they do this and this and that, right? So you make all of this prediction based on data that is existing. Then you now propose it to the company. Okay, so for us to meet these targets, everybody we need to do this, and do this, and do this. And then department will now work with that prediction to get it. So there are times when, of course, the prediction will, based on the prediction, they might not meet that target, but they'll be very close. While there are times when, based on the prediction, you'll be able to meet the target and pass that target. Do you understand? But if a data analyst in that case will not be able to do that prediction, you just use the data at the end of the month to just tell you that, oh, we wanted to meet 2,000 or 4,000, but what we saw was 2,500, right? But a data scientist will make predictions to ensure that at least we're able to meet 4,000. If we have to increase our work power in the company to make more products, if we have to get more vendors or more riders, or if we have to do this and that, whatever it is you have to do, they use data from the past to make prediction for the future. Do you understand that?
Yes, ma'am.
Okay.
All right. Thank you so much. So the last but not the least question: what are the common pitfalls or mistakes to avoid in data analysis?
Common pitfalls or mistakes. So the common pitfalls or mistakes to avoid in data analysis. Interesting question. Wow. I think that would be. Let's see. Let me see. I actually have to think about that one. Wow, interesting. Okay, so common pitfall would be say lack of data integrity, right? Not asking the right questions, right? So I'm going to explain all of that. So number one, when your data doesn't have integrity and you don't because they are like that, like I said, they are like frameworks that guide everything you do with data. Because data is very, very, like I said, intricate. And the higher the industry, the more intricate it will be, the more close-ended it will be. You have to be very focused, right? Whether it's finance, you can't make mistakes with finance data. You can't make mistakes with health data. You can make mistakes with sales data. They can pardon you, right? But when you make mistakes with finance data, money disappears. Are you the one that will pay? Are you the one that will refund the money? Okay, so their data is really, really like you can't make the mistake with data, and there are even more data that are more intricate than others, right? So one of the things that you can't make mistake with is data integrity. Your data must be like whatever. Before you even start analyzing, you must ensure that your data has integrity, right? You have to ensure that your data has integrity. Another thing that you need to do is I mentioned it just now. Okay, yes, like I said, you have to also if you're checking for data integrity, check for outliers, you check for a lot. Well, I think for me the most important thing is ensure that your data has integrity. Yes. And then also there's something that's coming to my head. I don't know why I can't. It's in my head, but I'm not able to like word it. So yes, data. Let's take data. If I remember something else, I'll mention it for the call ends.
All right. Thank you so much, ma'am. We've come to the end of
You're
this evening's section. Let me say it's insightful. So please let's celebrate our tutor, our facilitator. Let me see. Are you excited about this section? In the comment section. Thank you so much, Miss Doreen. Hope to see you tomorrow. And we are so prepared to learn more. So
Thank you very
Please
much. Thank you.
check the chat box.
Yes,
LinkedIn
I'm checking.
name is there.
Okay, so
So
I can see a question here.
okay.
Thank you from Juliet. I must commend your communication pattern. Oh wow, thank you. My question is this: is IBM not among the data tools? Okay, so IBM is a platform. IBM is an organization. In fact, it's like IBM is like Google. When you see Google, Google is not a data tool, but Google built data tool. IBM, they're the one that own Tableau, right? They own Tableau, and they also own a lot of other. I think they own. I think they're the owners of Postgres. I'm not sure, but I think they're the owners of Postgres. So they also have Amazon. No, I think they have a cloud service too that is not so popular. I think Oracle is by IBM. Like Oracle is a cloud service that is not so popular. Like the three that we have: Google, GCP, AWS, and Microsoft Azure. So AWS is from Amazon. Microsoft Azure is, well, of course, by Microsoft, and GCP, Google Cloud Service Providers, are from Google. So, but if IBM has its own, which is Oracle, they're just like the way Google would be. They build tools that help with data, but they are not data tools. Can we get today's training slides? Sure. I would. You can get today's training slides. I will send them to the group. So guys, follow me on LinkedIn. If you have more questions, you can reach out to me. If you need guidance, you can reach out to me. I can't even if I can't help you, I'll definitely direct you to somebody that can help you. And please, for ladies, for everybody, in fact, please always aim for the moon. I mean, how did they say? How does that go? Aim for the stars. Even if you don't get there, you land among the moon, right? So yes, please, let's try anything we want to do. Let's put our mind to it and definitely achieve. I mean, I know a lot of people that are doing well in the data world. And even if you try out data and you find out that's not something you want to do, it's also not bad. Like I said, I tried out a lot. Then I was a lot younger. I tried out front end. I wanted to do front end engineering. I tried front end. It was not front ending for me. It wasn't front ending at that time. I think I know I tried embedded systems. I tried game development. Those three, I know that. There were a lot for me at that time, right? Because I was really young. So but I mean, age does not matter, of course. But at that time, my head was not in the right place when I was trying. I was just trying it for my why was not my head exactly. My why was not profound. I was doing it because people were doing it. Everyone around me was doing it. I didn't have a strong why. But when I found data, I was able to understand my why, and I stuck with it and I pushed. And because of that, I was able to go fast. I've been in the data field for 4 years now. I did data analysis for a year. 2 years. I did data science for a year. So I transitioned from data analyst to data science in the same company. And then after I learned data engineering, I switched to a different company, and then now I'm a data engineer. So I can do all three, right? I can do all three. Now I'm currently learning software engineering. One of the reasons why I'm learning software engineering is because I want to be able to build solutions that can solve all data problems, right? So all this, I know how in the organizations software. Most organizations they don't understand. They don't, much in Nigeria, right? They don't really understand how to implement data, right? And most data analysts, because like I said, most data analysts will only know foundational knowledge. They don't really have much knowledge. It's always difficult because they don't have much knowledge. Most startups are always failing in terms of data. They don't have data foundation. So my idea is to bring up a tool that can help with that, right? Just like we have product management tools, I want to also have a data management tool. Yes, so that's why I'm learning software. So guys, watch out for me. So yeah,
Watch out for me too. Watch out for all of us.
all of you, yes, yeah. Thank you very much, Victoria. This was so fun. Thank you, everyone. Thank you, everyone, for being here.
Thank you for your time. We are grateful. See you tomorrow. Thank you, everyone.
Thank you so much, everyone. See you tomorrow. I'm looking forward to tomorrow. Thank you. Bye.
You don't